Hey math kids, today we're going to talk about binomial expansions, and let's see, we're going to start with just a discussion of Pascal's triangle. Maybe you've already studied this before in a previous class. Okay, we'll just go out there. The pattern goes to infinity, but what we do is we just add the two numbers above to get the number below. So 1 plus 1 is 2. Right here, 6 plus 4 equals 10. 3 plus 3 is 6. And it just grows like that. Now, a cool thing about Pascal's triangle is it actually has a lot of cool patterns built into it, but we can expand binomials. So if we have something in the form of a plus b raised to the n, then we can use that to expand this without using the distribution or whatever you would use in the past. Now, another cool thing about this is when we're talking about combinations, and so if we have like 5c3, the old way is going to be 5 factorial, 3 factorial, 5 minus 3 factorial. And so if we do that, we get 5, 4, 3, 2, 1 on top. We get 3, 2, 1, 2 times 1. Okay, and so my 3, 2, 1 cancels 3, 2, 1, and then we get 20 over 2, or 10. Now, there's some notation stuff. So this top row is actually called the zeroth row, first row, second row, third row, fourth row, fifth row, etc. So this number tells us which row to look in. And so if we go to Pascal's triangle, we're going to look in this row. Okay. Now, once again, this is the zero term, first term, second term, third term, fourth term, and fifth term within that row. The second number tells us which one to go to, so it's specifically that 10. So if we go to the fifth row, third element, keeping in mind that we start at 0, then that will tell us our combination every time. So we got a 10, specifically was that 10. And that's just how you can do a combination quickly if you already have Pascal's triangle memorized or you know how to generate it. Okay, now what we're going to do, we are given this binomial, triangle to expand it. So we only have to go to the third row on both of them. So I'll just do, and the third row is the one that has the 3s. That's another easy way. Okay, so we only go to the third row because of the exponent. Okay, then I'm going to write it spread out. I'm going to write it spread out. I'm doing both these at the same time. Hopefully that's not too confusing. Okay, I'll just focus on this. Okay, so now I'm going to take this, the first term, and I'm going to say 2x raised to the 3 because of this 3. Then I'm going to say 2x raised to the 2. You know what? I'm going to spread these out and just do one at a time. Okay, so I'm going to focus on this problem. So 1, 3, 3, 1. Now I'm going to take my 2x, and I'm going to say 2x cubed, then 2x squared, then 2x to the 1, 2x to the 0, which I wouldn't need to write. Now I'm going to focus on this 3 and do the same thing, but backwards. So 3 to the 3, 3 squared, 3 to the 1, and then don't write my 3. And then I just put some plus signs in between. All right, now it just comes down to simplification. So if I cube 2, I'm going to get an 8, and then x to the 3, and then the 1's not going to matter, multiplying by 1. Okay, if I square the 2, I get a 4, and then 4 times 3 is 12, 12 times 3 is 36. Then my x was squared. Okay, 3 squared is 9, 9 times 3 is 27, 27 times 2 is 54. Then we only have one x on that piece, and then 3 to the third times 1 would be 27. And so this is this expanded. Now, before this method, we would have had to write it out 3 times and made sure that we distributed and combined like terms correctly. But if we did that correctly, we'd end up with the same answer. Okay, let's try the other one. So once again, I'm going to focus on this one. So the x minus 5 raised to the third. I'm going to write out my third row of Pascal's triangle, spread out, 1, 3, 3, 1. Focus just on the x, so x cubed, x squared, x to the 1, no x. Now I'm going to focus on -5, but go backwards. So -5 cubed, -5 squared, -5 to the 1, and then no -5. And then I just put plus signs in between there. Okay, x cubed times 1 is just x cubed. -5 times 3 is -15. Then we have our x squared. -5 squared would be positive 25 times 3 would be 75. And then we have our x. Then right here is just -5 to the third, which is going to be -125. And then we times it by 1, which doesn't change it. So once again, if I expanded this thing up here, it would become this thing. Okay, we're going to do another one. So it wants us to write Pascal's triangle out to the 5th row is the first step. Once again, if you need help generating this, just come talk to me. Just remember you're adding the stuff right above it to create the stuff below it. Okay. Now it's asking us to expand x minus 2 over x to the 5th. So that's why they wanted us to write this out. This is a 10, by the way. That looks bad. Okay. So I'm going to zoom out just a little bit so we can write this spaced out a little bit better. So 1, 5, 10, 10, 5, 1. Just a little bit more. Okay. Okay, so we start with the first piece, which is just x, and we start at the exponent. So x to the 5th, x to the 4th, x to the 3rd, x squared, x, no x. Then we start with this piece at 5, but on the other end. So -2 over x raised to the 5th, -2 over x raised to the 4th, -2 over x to the 3rd, -2 over x squared, -2 over x to the 1, and then I'm not going to write anything on that one, because if we raise something to the 0, it is just 1, and that won't affect our multiplication. Okay, we put plus signs in between all of those, and now it comes down to simplification. All right. So if we do x to the 5th times 1, we're just going to get x to the 5th. So we got that figured out. Now, what we're going to do is we're going to multiply the numbers together. So we have 5 times -2, so that's -10. And then we have x to the 4th on top, x on the bottom, so we'll subtract the exponents, and that becomes x cubed. Okay. Now, this one, we'll need to simplify a little bit. So we're going to say negative 2 squared, so that's going to give us a positive 4. We still have our 10. And then we have x to the 3 on top, and then since we're squaring this on the bottom, it's going to be x squared on the bottom. So we have x3 over x2. So overall, that just becomes x, and that becomes positive 40. Okay. Then we move on to this one. So if we do this, we still have our 10. And then if we do negative 2 raised to the 3, that's going to be negative 8. And so those together make negative 80. Then if we deal with the x's, we're going to get x squared over x cubed, which is going to end with x on the bottom. So it's going to be like a 1 over x situation. So it's going to be negative 80 over x. You could also write it as x to the negative 1 if you feel better about that. Okay, this one we're going to get negative 2 to the 4, which is going to be positive, so this will be positive 16 times 5, and that's going to be 80. And then if we have the purple x right here is just x on the top, and then we have the white x that's to the 4th, so it's x to the 4th, which is going to be 1 over x to the 3rd, or x to the negative 3. I'm going to use this form though, so I'm just going to put that over that. And then the last thing, this 1's not going to matter, so it really just comes down to the stuff that's in white. So we get negative 32 over x to the 5th, because negative 2 to the 5th is negative 32, and x to the 5th is x to the 5th, and it's on the bottom. Alright, so that was a little bit harder, but we still just use Pascal's triangle. Remember, this tells us which row to look at. We write it spaced out, do x to the 5th, 4th, 3rd, 2, 1, and then we do the same thing with this going the opposite direction, and then we simplify, and that's what we end up with. Okay, that's all for this video. If you need additional help, please come to Math Lab. Until then, calculator.